targets for 2.1 are that will be able to simplify exponential expressions using negative and zero exponent properties, the product of powers property, the quotient of powers property, and the power of a power property, and the power of a product or quotient property. An exponent tells you how many blank there are of a number or variable. It's one of the F words of mathematics. Factors, how many factors there are of a number or variable. For example, 2 cubed is 2 times 2 times 2. There are 3 factors of 2. So you should be able to figure out at least up to here, most likely. You might get stuck on these and have to put them in your calculator. Take a moment to do that, but don't give me the decimal answer. I want it in fraction form. So take a quick moment to try that and see what you get for your table. If you did it correctly, these are the values you should have. 27, 9, 3, 1, 1/3, 1/9, 1/27, 1/81. Okay? Now we're going to talk about zero and negative exponents to understand where these numbers came from. Okay? So on the other handout, which has the rule of exponents, this is actually supposed to be a foldable for you to be able to, it got stapled in the wrong place. Fold it over so that you can actually study and know the rules. You should be able to cut on the lines so that you can flip them back. You guys didn't get them. I'll hand it to you right now. So we have, here, take one and pass it. Let me know if there's not enough. I'll grab extras later. All right, so we have negative exponents. First off, we need to talk about, so we should probably go back to the regular note sheet. We have this x to the n. I'm going to write that at the top. This right here, the number, that's called our base. And this up here is called our exponent, or sometimes called our power. But we're using it, that's our exponent, this is our base. So on our rules for negative exponents, a negative exponent is telling you that the, let me write it down, that the number is in the wrong place of a fraction. We cannot, to our answers, we only want positive, we only want positive exponents in our final answer. So I can do all the other things that we're going to learn about, but in the end, if I have a negative exponent, I have to move it. And what it's telling me is that it belongs in the other part of a fraction. Wherever it is, if I have a negative exponent, then that exponential expression, to make it positive, I need to move it to the other part of the fraction. Move it to the other part of the fraction. So the rule for this, there's going to be 2 that I'm going to write down. One of them is x to the negative n. Well, that means that right now I have x to the negative n over 1. It's in the wrong place. It belongs in the denominator. So that would be 1 over x to the n. Same number for my exponent, same base, I just made the exponent positive by moving it to the correct place in the fraction. I could also start with something like 1 over x to the negative n. That tells me, hey, it's in the denominator right now, but it belongs in the numerator. So I'd move it up and make it x to the positive n. Here's an example. 2 to the negative second. Well, I know that that's 2 squared, but because of the negative, it's telling me it's in the wrong place. So this is really 1 over 2 squared, and 2 squared is 4. So this is 1 over 4 when I simplify it. If I have x, 1 over x to the negative third, that means that that negative exponent tells me it's in the wrong place. So that would become x to the positive third. So going back to our other sheet, we have a couple problems. Oh, we have to finish up some rules on this, but let's go back to that table. This 3 to the negative first is actually 1 over 3. 3 to the negative second is 1 over 3 squared. 3 to the negative third is 1 over 3 cubed, and 3 to the negative fourth is 1 over 3 to the fourth. We have two more rules. It tells us right here we have to talk about invisible exponents and zero exponents. So on our sheet we have the no visible exponent. So I have a number like 2 or a variable like x. Well, there's no exponent on there. How many factors of 2 do I have? 1. How many factors of x do I have? 1. We don't write it. It's kind of like multiplication. We don't put a 1. We know that 2 times 3 can also be multiplied by 1 and still be 6. There's always a hidden 1 in multiplication. Just like this x. We don't have the 1 written there, but there's only one x here. It doesn't have a coefficient because we all know it's 1. No visible exponent means that the exponent is 1. There is one factor of whatever your base is. One factor of the base. Zero exponent. This comes back to, again, talking about factors and multiplication. So I have, let's do a 5. I have a 5 sitting there. What's hidden in multiplication? 1. It's really 1 times 5. Just like I have an x here, it's really 1x. But we don't write that 1, because why would I write 1 times 5 if it's just 5? Why would I write 1 times x if it's just 1x? We know that that's an x, that it has a coefficient of 1. So now if I tell you that it is to the 0 power, what does that exponent mean again? It means how many factors? How many factors of 5 do I have? 0. 0 factors of 5. Well, if I don't have any factors of 5 to multiply with that 1, then what number do I have? 1. If I don't have any factors of x to multiply with this 1, then I just have 1. So the rule for this is anything to the power of 0 is 1. Now some people get this confused with multiplying. They're like, well, wait, if I multiply by 0, it's 0. Yes, if you multiply. But we're not multiplying. We're saying how many factors we have. Since there are no factors of 5, there's nothing there that's a 5. It's just a 1 through multiplication of 1. There's no factors of x. All I have is 1. All right. So let's go to A through E. I'm going to have you see if you can do some of these problems. Okay, we'll do, I'll do 2 of them with you. We have 4 to the negative second. What does that mean? It's really what? 1 over 4 to the second, which is 1 over 16. 2 to the fifth, you could write out as 2 times 2 times 2 times 2 if you want. But it is 2 times 2, there's 4. 2 times 2, there's another 4. 4 by 4 is 16. Times 2 is 32. Try the next 3. Take a moment to try the next 3 on your own. we're good. All right, so you should be getting these answers. Any questions on those three? All right, let's take a look at our next exploration then. Here we know 2 cubed is really 2 times 2 times 2, and 2 to the 4th is 2 times 2 times 2 times 2. Well, how many factors of 2 do I have now? 7. 3 to the 4th is 3 by 3 by 3 by 3, and 3 squared is 3 by 3. In total, I have 6 factors. 4 x's and 4 x's gives me a total of 8. 6 y's, 1, 2, 3, 4, 5, 6, and 1 y is y to the 7th. So this brings us to our product of powers. What am I doing with those exponents that gets me from here to here? Adding, because I'm just adding up the factors. How many factors? You had 3 factors, now you have 4 factors. Put them together, you have 7 factors. So the product of powers, by the way, for all of these, they have to have the same base. So if I had 2 squared and 3 to the 5th, I couldn't do those exponents together. They'd have a base of 2 and a base of 3. They have to have the same base. X to the a times x to the b is x to the a plus b. I'm just saying, hey, you've got this many factors and this many factors, add them together. So, x to the 7th times x to the 6th would be x to the what? 13th. X squared times x cubed, x times x, x times x times x, x to the 5th. I'm putting that on this, so if you reference this, you see the reason why. Go to the next page, or back to the original page, and try some of those problems. Let's do a couple together, though. So the first one, they both have the same base, so I'm going to put those together. The 3 and the negative 6. That's going to be 5 to the 3 plus negative 6, which is 5 to the negative 3rd. Can I leave my answer like that? Nope. I need to write it as 1 over 5 to the 3rd. And 5 times 5 is 25, times 5 is 125. So it's 1 over 125. I added my exponents. I took the negative exponent, moved it to the bottom, and then I cubed the number. Let's take a look at, I'll let you pick one other problem that you'd like to see worked out. I see one right now that you might want to see. G? You can do G. Oh, G. Well, you're going to work on all of them. What's the exponent on this x? 1. Do we see a plus sign in here at all? No. We are not going to distribute. There is no addition or subtraction of terms in the parentheses that requires to distribute. This is all multiplication. I'm going to do the ones that have the same base together. So I'm going to do x to the 1st times x to the negative 4th, and y cubed times y, which that y is also has an exponent of 1. This is going to give me x to the negative 3rd when I do 1 plus negative 4. And the 3 plus 1 will give me y to the 4th. But wait, there's more. What stays in the numerator? Y to the 4th. But x to the negative 3rd is in the wrong place. So to make that a positive exponent, it moves to the denominator. Try this for the other letters. We'll go over them in just a second. All right. Our next thing that we're looking at, we're kind of exploring division. We have 7 factors of 2 in the numerator and 2 factors in the denominator. So 2 of those cancel to be, oops, I crossed off the wrong one. That cancels to be 1, and that cancels to be 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So I'm left with only 5 factors. I have 9 factors of x on top. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5. I cancel 5 of them, and I'm left with 4 factors. on top. And for our last one, I have 3 factors of y on top and 6 factors in the denominator. And when I cancel them, I only have 3 factors of y left in the denominator. What number do I put on top? Well, I just put a 1, right? Because there's a 1 hidden in the multiplication up there, so it's 1 over y to the third. Now, how do I get from here to here? What could I do with the exponents? Subtract them, right? This is 2 to the 7 minus 2, which is 5. X to the 9 minus 5, which is 4. Y to the 3 minus 6, which would actually give us y to the negative third, but we don't leave our answer as a negative exponent, so we'd move it back to the denominator. So on terms of our rules, if we go back to our rule sheet, our foldable, the quotient of powers, again, they have to have the same base. X to the a over x to the b equals x to the a minus b. Take the numerator's exponent, subtract the denominator's exponent. 2 to the 5th over 2 to the 4th is 2 to the 5 minus 4 is 2 to the 1st. And we could look at that if we wanted to, but I'm not. We're not going to do this for every problem. I'm only doing it on here because it's on this sheet. You can see how they cancel. So we're going to give the problems underneath this on the note sheet a try. I have 3 factors of x in my numerator and 5 factors of x in my denominator. So I do x to the 3 minus 5, which is x to the negative second. It's in the wrong place of a fraction, so I put it as 1 over x squared. Try this for letters B, C, D, and E. Remember, you can only do the ones together that have the same base. Be careful on letter D. What's the exponent on the 4 and the exponent on the 6? 1. So am I going to be subtracting those numbers? No, I'm going to be treating this as 4/6 times p cubed over p to the 10th. We know how to reduce 4/6, or we should. And then we'll use our rules of exponents for the p's, for the base of p. So try letters B, C, D, and E. Final answers for B and C are up there right now, and I'll put D and E up in a second. Any questions on B or C? So negative 2 minus 8 is t to the negative 10th, and you move it down to the bottom. For letters D and E, the 4/6, both are divisible by 2, giving us 2/3. 3 minus 10 is p to the negative 7th. Since it's in the wrong place, we move it to the denominator. 2 minus 7 is x to the negative 5th, so that has to come down to make it positive. 10 minus 1 is y to the 9th. Any questions on A through E? All right, we have 2 more things that we're going to look at. We're going to look at not all of these for the sake of time. We're just going to look at a couple. We have 2 to the 4th raised to the 3rd power. So it's 3 factors of 2 to the 4th is what that means. 2 to the 4th times 2 to the 4th times 2 to the 4th, which I'm going to skip this part because we already know what that means. Add the 4s. That's 2 to the 12th. Okay. X cubed to the 5th is 5 factors of x cubed. 3 and 3 is 6, and 3 is 9, and 3 is 12, and 3 is 15. This is x to the 15th. Y cubed squared, y cubed times y cubed, 2 factors of y cubed. Well, that's just y to the 6th. How could I get this last exponent using the exponents in the original problem? Yes, Carly. Multiply them. When I have a power on top of a power, an exponent on top of an exponent, I'm just going to multiply the exponents. So that's what we're going to put on the next page of our rules of exponents foldable. Power of a power, again, it all has to have the same base for this to work. But if I have x to the m raised to the power of n, that is x to the m times n. x to the m times n. So for example, 3 squared raised to the third is equal to 3 to the 6th power, because that would be 3 times 3, 3 times 3, and 3 times 3, 6 factors of 3. And 3 to the 6th is 729. So we're going to go back to our main notes where we have our examples and our explorations. We have x to the third raised to the fifth. That's 5 factors of x cubed, which is x to the what? 15th, because I just do 3 times 5. Here, this would give me 2 to the negative 6th, which would become 1 over 2 to the 6th. And 2 to the 6th is 64. So it would be 1/64th for letter B. What would letter C become? Y to the negative 8th, which is 1 over y to the 8th. And letter D would just become m to the 20th. We have one final thing to look at. There are a couple more on our exponent rules sheet, but we'll get to those later. For today, this is the last exploration and set of problems we're going to do in class. So notice here I have 2 bases. What's the exponent on both of those bases? 1. I have a to the first, b to the first. Here I have m squared, n to the first. P to the first, Q to the first, R to the first. If there is not an exponent, you should probably put a 1 so you don't make a mistake, especially if there are numbers involved. So here, this means I've got 4 factors of a, b. You regroup them, that's a to the 4th, b to the 4th. Right? Same thing as before. We're distributing the exponent, but we're distributing it to both exponents inside. So this is m to the 6th, 2, 4, 6. M to the 6 times n cubed. So all we're doing is taking this outside exponent and distributing it to the exponents inside the parentheses. So when it says product or power of a product or quotient, I have x to the a times y to the b over z to the c. And I have this exponent m on top of all of them. Okay? And so I need to distribute it to every base in there. This needs to be distributed to its exponent. So this is going to equal x to the am, y to the bm over z to the cm. So it's being multiplied by every exponent inside those parentheses. Not the base itself. Don't multiply it by the base. Multiply it by the exponent that's on the base. So when I see an example or a problem like this, 2m squared over n cubed, and I'm raising it to the 3rd power, what are the 3 exponents, or what are the 3 bases in the parentheses? The bases are 2, m, and n. What are the exponents? 2 and 3, and this one is 1. The common mistake people make is they are so used to distributing, they're thinking, oh, I'm going to distribute 3 times 2 is 6. You're not supposed to multiply the base with the exponent. You're supposed to multiply the exponent with the exponent. So this actually is 2 to the 3rd, which is not 6, m to the 6th, and n to the 9th. 2 to the 3rd is 8. So that would be 8m to the 6th over n to the 9th. Distribute to the exponents, not to the bases, especially when it's a number. You're going to want to multiply those. Don't. Make that the exponent on the 2. So give these last 5 problems a shot. See if you can get the right answers on A through E.